Hi guys, welcome back to Math with OG. Still on set, we'll be looking at the cardinality of a set. You must have heard the word cardinality before on that set. So what does it actually mean? Now, as you can see on the board, the cardinality of a set A denoted by NA. So you must have come across question. You'll be given a set, let's say B or Z or whatever. You see what is NZ. You'll be wondering what does this mean? This simply means the cardinality of the set is the number of distinct element in a set. The number of distinct elements in a set. Take note of the word distinct. That means the number of different elements in a set. Now you see where that will come into play when we get to equal set and equivalent set. Now distinct means different elements. So the number of different elements in a set are is the cardinality of the set. That's the number of elements you can find in a set. For example, you have a set A equal to 2, 4, 6 and 8. The cardinality of the set is equal to 4. Why is it 4? We have 4 different elements in the set. Now let's assume I create a set B and this set B is equal to A, B, C, A. The cardinality of this set is 1, 2, 3 and not 4 because A is repeating itself. You might be wondering, if A is repeating itself, why do we have two elements in or two the same elements in set B? How is that possible? I think I will explain this better when we get to equal set and equivalent set. You will see why you can have two the same elements in a set and that does not mean that the cardinality is 2. These two guys is still 1, then you have 2 and 3. So the cardinality of this set is 3. Now we also call the cardinality cardinal number. We also call the cardinality cardinal number. So the cardinal number of this set is 4, while the cardinal number of this set is 3. Now based on cardinality, we have different types of sets. Based on cardinality, we have different types of sets and we usually divide them into finite sets and infinite sets. And it comes from the word finite and infinite. What is finite? Means that you can count the number of elements. So when the number of elements is countable, it's a finite set. However, when the number of elements is not countable, it is called an infinite set. Now that we know that the number of elements is countable, we still have some special cases of countable sets. That means some special cases of finite sets. And those two cases are null, empty, or void sets, which we represent by two curly bracket, that is opening bracket, closing bracket, without including an element inside, or represent with the symbol phi. So this is what we use to represent null, empty, or void set, or this symbol. Now we have the other one, singleton set or singleton set. It simply means a set having just one element. It simply means a set having just one element. So if I have a set, let's say B, to be equal to a set containing just dog. A set containing just dog. I know the writing is small, but this is dog. This kind of set is called a singleton set because it has only one element. Now, if a set C is not containing any element at all, we call that an empty set, a void set, or a null set. You'll be wondering, how can we form a set that is empty? For example, I ask you, give me a set of days of the week beginning with Z. I believe you cannot find any day of the week beginning with Z except you want to form a Sunday or a Someday, as the case may be. So there's no day of the week beginning with Z. So therefore that set should be an empty set. So that's that for finite set, infinite set, null, empty, void set, singleton set. So these two guys are finite sets because you can count them. This is 1 and this is nothing. While this guy is on his own as infinite set. Now, can you see question based on this? Yes, you can see question based on this. Now, you can see a group of sets, a well-defined set. Now, the question is, this set, which of them is a finite set? Which of them is an infinite set? Now, if it's a special type of finite set, like a null set or a singleton set, also tell us that it's a null set or a singleton set. So that's what we have on the board. So let's play with these questions together. The first set B is equal to minus 1, 1, 3, 5, and 7. So what type of set do we have there? It's not an empty set. It's not a singleton set. It has 1, 2, 3, 4, 5 elements. So we can call that an infinite set. We can call that a finite set. So that's a finite set, not empty, not having just one element. Now the second question, The set of even numbers exactly divisible by 5. The set of even numbers exactly divisible by 5. Now, I can see that even before getting to real numbers, we're having questions that have to do with our understanding of real numbers. Now, you should note that the set of real numbers is an infinite set. The set of real numbers is an infinite set. That's why when you draw your number line, you see to the right is tending towards positive infinity, and to the left is tending towards negative infinity. So we have an infinite amount of real numbers. Not just real numbers, the set of integers, which are just whole numbers, is also an infinite set. We have an infinite we have an infinite amount of whole numbers. So when you're writing 1, 2, 3, 4, 5, 6, 7, 8, you will keep writing to a point that it will be tending towards infinity. By now, you should know that infinity does not exist. But since whole numbers cannot get to the last part, we call them infinite. Even to the left, it cannot get to the last part, so we call them infinite. Now, down to prime numbers, okay, I don't know for prime numbers, but down to even and odd numbers, we have an infinite amount of even numbers. We also have an infinite amount of odd numbers. So if I ask you now, list out all the even numbers you have, you can start with 2 because 2 is the smallest even number. But when you are going, you can see that you will never get to the end. So how do you know that something is finite? When you know the beginning and you know the end, but it's still not also like that. Because when we get to this question, you understand why this guy is also infinite. So we have an infinite amount of real number, infinite amount of integers, infinite amount of rational numbers, infinite amount of irrational numbers. We also have an infinite amount of even and odd numbers. So if I have an infinite amount of even numbers, so I should have an infinite amount of even numbers that are divisible by 5. So since I cannot list out all the even numbers we have, we can't also list out all the even numbers that are divisible by 5. So this is infinite. This guy here is finite. Now the third one, the set of numbers up to 100 million. You might be wondering, the set of numbers up to 100 million, they are simply 100 million numbers. That is wrong. If I say the set of positive numbers up to 100 million, that is a finite set. Positive numbers up to 100 million, positive whole numbers up to 100 million, you are going to have 1, 2, 3, 4. You will keep listing till you get to 100 million. So I believe that is finite. It's countable, meaning you have 100 million positive whole numbers up to 100 million. However, we are told the set of numbers, that be it a rational number, an irrational number. So you can see that set of numbers up to 100 million, you have a number like this: 0.1, 0.01, 0.001, 0.0001, 0.00001. So by the time you are done, you find out that even the set of numbers between 0 and 1 is also infinite. So I come again, the set of numbers between 0 and 1 is infinite. However, the set of whole numbers between 0 and 1 is null. There is no whole number between 0 and 1. But if you ask the set of numbers between 0 and 1, it is infinite. That means we are starting with 0 and we are ending in 1. We have a whole lot of numbers here that we cannot count. Both rational and irrational number exist between 0 and 1. So if that's the case, if from 0 to 1 we have an infinite amount of numbers, now let's talk about from 0 to 100 million. So it is obvious that this guy here, we have an infinite amount of numbers up to 100 million. However, we have a finite amount of positive integers up to 100 million. But since they just gave us numbers here, that is rational, irrational, fractions, so we have an infinite amount of numbers. Next question, set of letters of English alphabet. I believe they are from A to Z, which is countable. So the set of letters of English alphabet is a finite set. Is a finite set. Now the next one, we have a set on the board starting with minus infinity down to infinity. As you can see, this thing means that it is tending towards minus infinity, and this guy means it is tending towards infinity. Like I said before, and I'll say it again, infinity does not exist. It's just somewhere that numbers tend to. that we don't know because we don't know the end. The same thing is happening here. So this guy is infinite. We have an infinite amount, or this set is an infinite set. Next question. The numbers of people that are 10 meters tall. The numbers of people that are 10 meters tall. Now you can use your height as a reference to find out if someone can actually be up to 10 meters tall. So if I say the number of people that are, if I use the word 1 meter tall, or more than 1 meter, or between 1 meters and 2 meters, I can say the answer is finite. Because we have a finite number of people in this world. We're about 7 billion plus or 8 billion plus. But as long as we can be counted well, it means that we have a finite amount of people in this world. But for someone to be 10 meters tall, like someone like me, I'm 1 point something, about 1.8, between 1.8 and 1.9. So for someone to be 10 meters tall, the person should be at least 5 times as tall as me. So 10 meters tall can be argued that it's like, let's say, one story bridge. That is a house on top of another house. That's almost 10 meters tall. It might not even be up to 10 meters tall. So as you can see, it is almost impossible, not almost, it is impossible for a normal human being to be 10 meters tall, because I don't even know how the organs will be placed in a person's body if someone is 10 meters tall. How long will his skull be? How long will his legs be? So this is not possible. So this guy here is an empty set. Empty or null set. Next question. All the odd numbers that are divisible by 2. Odd numbers are numbers that are not divisible by 2. That's the definition. So we have no odd number that is divisible by 2. So this set 2 is also an empty set. Next question. The set of points on the circumference of a circle. So for those of you that have done maths to a large extent, you will understand that the definition of a circle is a locus of points, a locus of infinite amount of points is what a circle is. So this is a circle. This is not a perfect circle, but let's assume that what we have here is a circle. So the number of points here that make up this circle is actually what? Infinite. It cannot be counted. Just like the hair on your head cannot be counted. So this guy here is infinite. The set of points on the circumference of a circle is infinite. Next question. All prime numbers between 1 and 500 billion. We have beginning and end, and we know that prime numbers are whole numbers. It means that we can list out all the whole numbers from 1 to 500 billion. You can list out all the whole numbers. Suppose you were told all positive whole numbers between 1 and 500 billion, it is finite. Now you are told all prime numbers between 1 and 500 billion, it is also finite. It might not even be up to 1000. That's the cardinality. It might not even be up to 100. But prime numbers does not follow a sequence. So this guy here, we have this to be a finite set. Lastly, the set of square numbers. The set of square numbers. Firstly, you ask yourself, what are square numbers? Square numbers are simply the square of whole numbers. The square of whole numbers are square numbers. For example, 1 all squared. Whatever you get as your answer is a square number. Move on to the next. 2 all squared. Whatever you get as your answer is a square number. Move on to the next. 3 all squared. Whatever you get as your answer is a square number. 4 all squared, you have what? 16. So you have 25, you have 36, you have 49, 64, 81, 100, 121, as the case may be. So all these guys are all square numbers. Now, for you to have a square number, you must have a positive integer. For you to have a square number, you must have a positive integer. Positive integers give birth to square numbers. So the set of all positive integers, that is what? An infinite set. Because you cannot list out all the positive integers we have in mathematics. So the set of square numbers is simply the square of infinite amount of numbers. So your answer should be what? An infinite set. So this guy here is simply an infinite set. So that's that for cardinality of a set. Cardinality of a set. Now in our next video, we'll be moving on to equal sets and equivalent sets. What does it mean for two sets to be equal or more than two sets? And what does it mean for two sets or more than two sets to be equivalent? We'll be looking at that in our next video. Now, thanks for watching this video. If you like the video, kindly use the like button. Also, don't hesitate to subscribe if you've not done so already, and also share to friends. And if you feel that there was an error in anything we did, use the comment section, and if there's any question you want to ask, also use the comment section. Thanks for watching once more, and see you guys in my next video.